Alright, let's start on the practice problems with number 7. I've chosen not to do a one where we test a solution, where they give you a system and what's supposedly a solution, or several possibilities for solutions. Um, if you want an example of how to work through a problem like that, and I'm only choosing to do this because I've only assigned one problem of that. If you need to be walked through a little bit the process, then just take a look at the intro video. Skip the first intro, where I talk about the graphs and planes and things, and there's an example of it. You're not too far into it. Maybe, well, actually, it might be like 10 or 12 minutes into it. So take a look at that. Anyway, here we go. So number 7, we're going to actually find the solution using back substitution. Always remember to skip through these boring parts where I'm just writing stuff down. I promise not to say anything important. Okay. So what we're going to do is, first we can talk about this for a second. Remember that a solution is going to be an x and a y and a z that all go into these three equations and solves all of them, makes all of them true. Meaning that if I put the same z here, here, and here, the same y here and here, there's just nowhere to put a y here, the same x, well, here, well, there's nowhere else to put it, but I put the x there with the same y and the same z as these two. For this one I'll get 10 and 12 over here and 2 over here. And the thing that we notice is z is already given. Z is 2, so 2 should work here and here and here. If 2 works for z here, and it works here, then I should be able to just substitute it in and find y. So let's come over here and make that substitution. Y plus 2 equals 12. Y equals 10. Alright, so y is now 10, z is already been given, it's 2. And let's put y and z into this equation. 2x plus y, which now we put as 10, minus 3 times 2 equals 10. 2x plus 10 minus, this is 6, so 10 minus 6, that would be a positive 4. 2x equals 6, x equals 3. So our solution is 3 for x, 10 for y, 2 for z. Remember, this is the final answer, like this. Not scattered all over the place and just circled, but finally put into this form. That's your final answer. Alright, let's go on to number 12. This is just where we practice row operations. Making sure I got that correct. Okay. So now we're going to just, we're not doing anything fancy, we're just doing the operations that they tell us to do. And that is to add -2 times equation 1 to equation 3. And to just kind of state what happened. So let's make sense of what they're asking us to do. It says add -2 times equation 1 to equation 3. So what I hear there, the most simple thing I hear is adding. I'm going to add two equations together. And the simplest equation I hear is equation 3. So equation, there, I'm missing something, am I? Yes, I'm missing a 2x. Please forgive me. Okay, so we're going to add equation 3 to something. Alright, so maybe I'll just put that over here. 2x minus 3z equals 0. I'm going to add this to something. What am I going to add it to? -2 times equation 1. I'm going to take a -2, and multiply it by equation 1. I'm going to take the result of negative 2 times equation 1, put it here, add it together. And negative 2x plus 4y minus 6z equals negative 10. Let's add it together. These guys cancel. 4y plus nothing is going to be 4y. Negative 6z minus 3z is negative 9z. And 0 minus 10 is negative 10. So what was the result? We've got a new equation that has no x's in it, and it's just left with y and z. And if you watched the intro video where we worked a problem through, this is a good thing. Canceling out this x is a good thing. So, that's what happened. And that's all we really need to do with that problem. We added as they said to, and the x's got canceled. So we could replace this equation, since it was one of the ones that we used, we could replace it with this guy right here. And that would be a good thing, because we would get it into row echelon form. Right. Now let's try number 20, and let's give ourselves some room. Alright, look at that. I just took out the boring part for you. So now here's number 20. It's written down. And they say find the solution algebraically. And this is the part where I get a little satisfaction, because using graphing calculators here, at least the ones that most of us have, including myself, they don't do 3D graphing. So there's no graphing solution to this. So you've got to now actually do the math. And I'm sure you're all ready for that, and that's great. So what should we do to solve this algebraically? Well, it just means, from the intro video, remember, that we are going to take this system, do elementary row operations like we just practiced in the previous problem, to get this system into row echelon form. We're going to step down like this, or get it to be in that shape. And we're going to do that somehow by trying to add equations together, as we did in two variables, two equations and two variables. We're going to try and cancel things out, and eventually we'll cancel it out in such a way that z will be left, and it'll just be z equals a thing, and we'll know what z is. Or maybe 3z equals 9, and we can find z very easily. So let's get started on that. How can I, first of all, your first goal, if I were to set a Roman numeral 1 next to this step, I would say get rid of, two x's like this. Whether you move stuff around, whether you multiply an equation by something and add it to another equation and cancel it out, whatever you want to do that, cancel out the x's. Okay? And to do that, I'm going to choose to take this guy and just make them all negative. And we'll see what that looks like. That's going to be a negative 2x plus 4y. I'm sorry. That was, awful. Come back over here. Minus 4y minus z equals positive 4. Okay. And what I'm going to do is, if you can look here and there, this negative 2 is going to cancel with this positive 2, so I'm going to rewrite this guy over here, and all of this writing is just to help me keep it all straight. You don't have to write down this much stuff if you don't want to, but make some kind of notes to say, this is what I did here, and I added these two together, and then write your new thing down here. Alright, so now we do negative 2x plus 2x is going to be 0 x's. Okay, so I'll write the result here in this color. No x's. Negative 4y minus 4y is negative 8y. And 6z minus z is 5z. And 13 plus 4 is 17. So you see how we don't have any x's anymore. So this is going to come in. We're going to write our system again, and all we've done is alter this equation. We haven't changed its value. We've only added two equations together, and that's perfectly legal. if as long as I do the same thing to both sides, I haven't changed the value. And this is the same as this, and I've added 4 to this side, and the same thing as adding 4 is adding all of this. I've added all of this to this side, and here's the result. It'd be the same if I divided both sides of this by 2, or added 3, or whatever. I've done the same thing on both sides. Here's the result. I've only changed its appearance. I haven't changed the truth of it. The same y and the same z need to go in here, as need to go in here, as need to go in here. Okay? So let's rewrite our system, our new one. 2x plus 4y, that's still going to be our first equation, plus z equals negative 4. This is going to come in, and it's going to be our second equation. 2x minus 4y. I'm rewriting the same one we already had. Right, this here. No x's, negative 8y, plus 5z equals 17. And the third one is unchanged. Okay. And now I want to get rid of this x. Right? Clearly I'm going to use this thing to cancel out this x, because this has no x's to use. This is the only tool I have. And the way I'm going to choose to do that is, if I need it negative, because it needs to cancel out this positive, so it needs to be negative, and I want it to be a 4, so negative 2 is what I'm going to use. And let's bring it over here. So that's going to be a negative 4x minus 8y minus 2z equals a positive 8. And I'm going to take this thing and add it to this thing, because the 4x and the negative 4x are going to cancel. So 4x minus 2y plus z equals 6. I'm going to add them together. The result will be no x's, negative 10y, negative z, and 14. That's going to be my new third equation. So same first equation, 2x plus 4y plus z equals negative 4. Same second equation, negative 8y plus 5z equals 17. Now our new third equation is going to come in here into the third slot, negative 10y minus z equals 14. And now, remember the goal is to get into row echelon form. We're not quite there, but we've got this first little step thing. Now we're going to need to cut in here and be able to not have anything in this space. How are we going to do that? Well, we got to find a way to get as many y's here as we have the opposite number of y's here, right? We need to have positive 2, negative 2, or something like that. So I'm going to choose to do a couple things. This one I'm just going to make this one positive. Okay, so I'll make this a positive, looking for a common multiple here, a positive 40 is the first one that I see. Yeah, so negative 5, and I'll make this a positive 4. Okay, so this negative is going to change this to a positive, and this will be 40, and this will be a negative 40. Okay. So this one is going to be a positive 40x minus 25y equals negative 85. Let's see. Nope, 85 was right. Negative 85. Just doing that in my head. I should really grab a calculator so you don't have to wait on me for that. But negative 5 times 17 is going to give us negative 85. 4 times negative 10 is negative 40x. 4 times negative z is negative 4z. And that equals 4 times 14 would be 56. Yep, 56. go. Here is pay dirt right now, what we're going to get. Negative 40 and 40 cancel. There's no x's left. Negative 29z equals negative, I am going to grab my calculator, negative 29. What a great coincidence. Alright. I'm going to move this down a little bit so that we can see what we've accomplished. I'm going to use a different color just so it is easy to distinguish. So our first equation is the same, 2x plus 4y. Make a distinction here. Plus z equals negative 4. Our second equation is this thing here, negative 8y plus 5z equals 17. And this guy here, z, is equal to 1. Right? I kind of fudged it a little bit. I did a little math in my head there. Divided by negative 29 on both sides, and we get z equals 1. Well, hooray, because z equals 1, and now negative 8y. Oh, this is no good. This is a terrible color selection. Negative 8y plus 5 times 1 is 5. Right? I'm putting 1 in there for z. Negative 8y is equal to 12. So y is equal to a negative 12 over 8. And so this would be a negative 3 halves. Yeah? Okay. Now, when you get an answer like this, I know it freaks you out, as it does me sometimes. But that's a little bit of satisfaction comes from knowing that all your math is on, you've done all your steps correctly, you've been meticulous, and you have confidence that this is right. And you say to this problem, you know, you're not tricking me. I know that y is negative 3 halves because I know I've done everything correctly. And I usually go back when I get an answer like this and make sure that I haven't made any mistakes. And when I'm sure that I haven't, I just have confidence that that this is correct. So now we know that y is equal to negative 3 halves. Z is equal to 1. And now we just need to find x. And I don't like getting rid of that work up there, but we are running out of room. So let's take this, 2x plus 4 times, I'm putting this y and this z in this first equation, 4 times negative 3 halves. That's going to cancel out nicely. Plus 1 equals negative 4. 2x minus, right, this is going to cancel the 2 with the 4, so become a 2. And negative times positive, negative 6. 2 times 3 is 6, plus 1 equals negative 4. 2x equals, I'm going to add 6 to both sides. That's going to come up with a positive 2. Subtract a 1, that's going to come up with a 1. And so x must be 1 half. Okay, so now the solution is 1 half, comma, negative 3 halves, comma, 1. There's our final answer. There we go. So let's move on, and we are going to next go on to number 18. Alright. So number 18, we're going to try and, again, put it into row echelon form so that we can do back substitution and find the solution. Now, here's where a row operation comes in that we didn't use the first time, and that would be switching rows. What you'll remember is that we want is, you know, like an x here, and then no x's here, but a y, and then no x or y in this final one. And you'll see this guy right here already does not have an x. So we might want that one to be the second equation rather than the first, because, you know, some work is kind of already done. So why don't we switch this one with this one. We'll switch the first and the third. Okay, so we're going to switch these. That's that first elementary row operation that we can do. So 2x and then a minus 3z equals 12. The second one will leave the same. 3x plus 3y equals 9. And this, nope, we don't want that. We want to switch. We want this to wind up as the second one. So we want to switch actually these two and not these two. Alright, so 3x plus 3y is going to be our first equation, and 6y plus 4z equals negative 18, and 2x minus 3z is equal to 12. Alright, so sorry for the confusion there, but switch the first and the second ones, and the reason being is that this one, already some of the work is done, this x has been canceled out. So we only need to cancel this guy out, and then we'll go from there. So to cancel those x's out, let's do a negative 2 here, a 3 here. That will have a negative 6x and a positive 6x. Negative 6x minus 6y equals negative 18. And 6x minus 3, let's see, 6x minus 9z equals 30, what were we looking at here? 36, yeah. And what we're going to do is add those together. Add these two equations together, we wind up with no x's, but then we have a negative 6y, negative 9z, and that is equal to 36 minus 18. And that is 18. So we have this new third equation where we've canceled out this x and we have a new thing with no x's left. So let's rewrite that. Same first one, 3x plus 3y is equal to 9. And don't worry that there's no z here. What we're looking for is this shape over here, that we have a lack of x here, lack of x, lack of y. Okay, 6y plus 4z equals negative 18. And this one is this new guy here. Negative 6y minus 9z equals 18. Well, this is going to be really nice to us because remember the last step that we want to do is cancel out this final y, and then we'll have our row echelon form. So if we just add this one and that one, we'll have our new one. So let's just do that. 3x plus 3y equals 9. 6y plus 4z equals negative 18. And we add these together now, and that's going to replace the third one. So 0y, 4z minus 9z is negative 5z, and negative 18 plus 18 is 0. So immediately we know z must be 0. If we divide by negative 5 on both sides, z would be 0. We can put that in here. That would make 6y equal to negative 18. Divide by 6 on both sides, y is equal to negative 3. Take 0, put that in for z here. There's no z there, so we're just going to put negative 3 in for y into that first equation. So 3x plus 3 times negative 3 is equal to 9. 3x minus 9 is equal to 9. 3x equals 18. X equals 6. So our final answer is 6, negative 3, 0. Alright, and that was for number 18. Alright, now let's put that back up there. Let's go to 21. And I'm going to pause this. Alright, doesn't seem like I paused it, but I did. I wrote all that down. So let's go for this. Let's try and do this system. Now, one thing hopefully you've noticed by now is we start off pretty much using this guy up here as a tool to cancel out these other x's. So look at all three of these equations and think, which one might I want in the first position so that it's easier to cancel their stuff out. If I have this up here, it's going to be a lot easier to multiply this by a negative 3 to cancel with this, a negative 2 to cancel with that. Right? Hopefully you see what I'm saying. If you don't, I'm about to switch them, which is something we're allowed to do. And then you should see what I'm talking about. Let's switch colors here. This is now the first one, x plus y minus 2z is equal to 3. And then this is the second one now, 3x minus 2y plus 4z equals 1. 2x minus 3y plus 6z equals 8. So hopefully you see what I mean. We're going to cancel out this x. It's way easier to just multiply this by negative 3. And then I can also do it again the second time with this one, multiply this by negative 2. So let's set these two up to cancel each other. Let's just multiply this by negative 3. Actually, we don't have to do anything to this one, so we'll just say we're multiplying by 1. We're just leaving it alone. Negative 3x minus 3y plus 6z equals negative 9. Don't forget to multiply everything by this negative 3. That could mess you up. I see a lot of times maybe this 3 doesn't get multiplied by the negative 3. Just got to be careful. This one stays the same. 3x minus 2y plus 4z equals 1. And we get no x's, they cancel out. Negative 5y plus 10z equals negative 8. That's our new second equation. Okay. And, we've done enough of these. Hopefully, I can do this. I'm going to try and save some space and do this second one over to the side. Right, we did the negative 3 times this equation to cancel with the second one. I'm just going to come way over here and cancel with the first and the third. And then we'll write the new thing all together at once. So I'm going to take this guy, I'm going to multiply it by negative 2 this time. So I'll just use purple. You'll know that this is going to transfer to the purple. Negative 2x minus 2y plus 4z equals negative 6. This I don't have to do anything to. It's going to remain 2x minus 3y plus 6z equals 8. Now, let's bring the answer in as like a yellow. Canceling the x's, negative 5y plus 10z equals 14. Okay, here's our new second equation, our new third equation. Canceled out the x from the second equation, that's that. Cancel the x from the third equation, that's what that is. We're going to bring those down. Let's do black. So, same first equation, x plus y minus 2z equals 3. New second equation, negative 5. Oh, you know what, we should not put it there, that might be confusing. Sorry, this is taking a second. So we should put this up, line it up with the y's. Negative 5y plus 10z equals negative 8. And this guy's going to come and be our new third one. Negative 5y plus 10z equals 14. I want you to take a second and look at these equations. See if you see any patterns. You might notice that we have negative 5y plus 10z, and right underneath it, negative 5y plus 10z. And remember, I'm supposed to be able to put the same y and the same z into all three of the equations. Is there any way I could find a y and a z that I could plug it into exactly the same thing here, and one time get negative 8 and another time get 14? It shouldn't be able to happen, right? And if we keep following what we're supposed to be doing for row echelon form, we could bring this over here. We could, let's make this multiplied by a negative 1 so that we can cancel out the negative 5s, or cancel out the 5s. So this will become a positive 5y minus 10z equals 8. And this will be the bottom one, negative 5y plus 10z equals 14. So we go to cancel these out so that we'll have our last row, z equals something, but we're going to get nothing, nothing, so 0 equals 14 plus 8. That'll be 22. And 0 does not equal 22. And remember from our two variables, two equations and two unknowns, 0 equals 22, that's a false statement. And a false statement means, there is no y and z that I can put in here that would make both of these true. There's no y and z that will affect this falsehood. So this would be, no solution, we could say. And that's it, And the book will tell you, they'll use this word, inconsistent. Okay, we won't really go into why they use that word, but that's the word they use, and when they say that, it means no solution. It just means there's no x, y, and z that's going to work for this system. Okay, so that's the moral of that story. Let's see if we can find one. Let's go with 25. Alright, it's all written down now. So we're going to go after 25. We're going to see, can we find the solution to this system? And it's very similar to what we just had. We've got a single x, like a 1x here, 2x here, 3x here. So to start with, we're set up to cancel out the x's as we go along. So let's get started on that. Let's multiply this one by a negative 2, and this by 1, just keep it the same. Negative 2x minus 4y plus 14z equals a positive 8. This one will stay the same. 2x plus y plus z equals 13. And adding these together, we find our new second equation that we're going to replace our second equation with. Nothing, negative 3y plus 15z equals 21. That's our new second equation. Let's switch to black. So same first equation, x plus 2y minus 7z equals negative 4. We're going to take this is going to be our new second equation. Negative 3y plus 15z equals 21. Alright. And now we still have this third equation to deal with. 3x plus 9y minus 36z equals negative 33. And to cancel out this 3, I'm going to multiply this by negative 3. So negative 3x minus 6y plus 21z equals positive 12. 3x plus 9y minus 36z equals negative 33. solution is going to be nothing here. We're going to have 9y minus 6y, that'll be 3y. This will be 21 minus 36, that'll be 15, but it'll be negative 15z equals 21, negative 21. This is going to be our new third equation. Let's write it in yellow now. Same first equation, x plus 2y minus 7z equals negative 4, negative 3y plus 15z equals 21. 3y minus 15z equals negative 21. Okay, good. Now our final step in getting it down to row echelon form. First step being cancel this x, next one cancel this x, the last one would be cancel this y. Well, that's pretty nice. If you're looking here, these already cancel out, so why don't we just go ahead and start to write our new system. Here's our second one. Okay, now our third one's going to be when we add these together. So nothing, nothing, so 0. Maybe we have no solutions again or something. Oh, but we have 21 minus 21 is 0 as well. 0 equals 0. What did that mean before? It parallels directly to what we had before in 2 equations and 2 unknowns. It means there's an infinite number of solutions. Now let's go back. Let's think about, we don't have to actually go back, but let's think about those planes. Remember how we talked about there's an infinite number of solutions. That much should be clear, because if we find an x, y, and a z we can put in here, they're going to work automatically, I guess, in this third one. They're not going to change that this is true, right? And what happened essentially is that this and this second one and this third one from the very beginning were actually identical. They were identical equations. So that's what happened. We've got this plane and it's shooting off somewhere. This is shooting off in a different direction, but this is exactly the same as this one. So what do we have then? We have, let's say we have some plane like this, and let's say there's another one that's like this. You have to use your imagination that this represents something that goes on forever. So this keeps going this direction forever and ever. Right, this plane. And so does this one. And somewhere in here they're going to intersect maybe something like this. It's going to be this line that it goes on forever too, because these planes go on forever. So there's this line that shoots off like a laser beam off into three-dimensional space, and anywhere on that line is a solution to the system, because remember, the third plane was exactly the same as the second. So it just lies right in the exact same place as this plane. And so all we need to worry about is the points on this line, and all points on that line will be a solution to the system of equations, to all three equations at the same time. So our answer is not going to only be infinite solutions. We're going to tell how to find those solutions. And it's going to be, anywhere on this line in three-dimensional space, and we're going to tell you how to find any point on that line. And here's how we'll do it. Let's say that it doesn't really matter what you pick for z, apparently. At any z, imagine any, and as I move this back and forth, I'm moving it towards us and away from us. As anywhere on this z-axis that I choose to go, so way out here, I can find an x and a y that are going to give me a solution. So it doesn't really matter what I pick for z, but once I pick a z, then based on that I can find out my x and my y. And to show that, let's pick red. Let's say we just pick a z, okay? And this notation might get a little funny, but let's just say that for z, let's put it over here, we let z be some number a, okay? Whatever it is, 5, 6, 7, it doesn't matter. Any z that we choose is going to have a solution. So we take that a, and we kind of pretend like z equaled a. Instead of 0 equals 0, pretend z equals a, and now do the whole process of back substitution with this a. And then solve for y and solve for x. So let's plug in the a for this z, and we'll go with negative 3y plus 15a. And so negative 3y is equal to negative 15a plus 21. Just subtracted 15a from both sides. Divide by negative 3. It's going to be a positive 5a minus 7. Okay, so if z, let's start to write our ordered triplet. If z is a, that's our last part of it, then the middle part, the y part, is going to be take a, multiply it by 5, and subtract 7. That'll give you a y that works. Since we have a z that works and a y that works, let's find out the x that would work. And we'll choose to use green for that. That means I'm putting this value in for z, this value in for y, just like we did with the numbers before, but now it's with these variables. 2 times y, whatever y is, 5a minus 7, minus 7 times a equals negative 4. Try and make that really visible. So this will be x plus, distribute the 2, 10a minus 14, minus 7a equals negative 4. Combine like terms. 10a minus 7a is going to be 3a. So plus 3a minus 14 equals negative 4. X, I'm just going to go straight to the end. Add 14 to both sides. That's going to give you a positive 10. Subtract 3a from both sides. That's minus 3a. There it is. X is going to be 10 minus 3a. Remember, a is just the thing, whatever it is, that we pick for z. And we just did this kind of a imagining that z wound up equaling something. Well, it's just going to equal whatever we want. Alright? I know it's confusing taking z and pretty much changing it to a, but it's workable. Just give it some practice. Alright, let's do one more. Last problem on practice problems. Number 50. They're just going to give us -2 and 1. They're just going to give us a point in three-dimensional space. I know they're giving us, if we can remember our axes here, and I'm going to, those are on the paper, and this guy goes through the paper. It comes out of the paper this way and into the paper that way. And if we were going to graph this point, we would go -5 on the x, and -2 on the y, and then down 2. Right? And then on the z, we go +1. So helping us locate it, -1 is something like right there. So here's our actual point right there. And we want to find a system of equations that has that as a solution. Well, there's tons. Just imagine that you make 3 pieces of paper, 3 planes intersect there, and imagine all the different ways you could grab them and twist them and orient them so that they would all intersect at this point. There's tons of different solutions. So this solution I'm about to make up is not by no means the right answer. It's correct. It's a correct answer, but it's not the only one. So the way we could do it is just, let's say we do x plus y plus z. Why don't we do that? Well, this is the solution. So x plus y plus z is going to equal whatever it equals. It's going to be -5 plus a -2, so we're at -7, and then add a 1, so you're going to be at -6. There you go. How about if we just do x plus z, just leave y out of it, make it as easy as possible. X is -5 plus 1, that's going to be -4. And then make it really simple. Z equals 1. No problem there. There's a system. They don't necessarily have to have x's and y's and z's in every single equation. There's one that works. We can do one more. I'd like to start with this one again. Equals -6 still. Let's do x plus y minus z. That'd be -5 plus a -2, that's -7, minus 1, that'd be -8. How about x minus y plus z? -5 minus a -2, that'd be -5 plus 2, that's -3, plus 1, that's going to put us at -2. Right? Whatever you feel like doing, do that, and it'll be pretty simple. Just make sure each of these things is distinct from the other. You can't have x plus y plus z and x plus y plus z. Make them different from each other. But that's it. So I hope that was helpful.